So Marcella, let us know when you'd like us to get started. I know we're waiting on a slide or two.
Please go ahead.
Okay, do you want me to share the slide?
Let me share for you.
Okay, perfect, thank you. Okay, hi, my name is Jessica Lilly. I'm the Executive Director for the United States-Mexico Foundation for Science in our United States branch. Marcella, thank you so much for all the organization for today's session. Before I introduce my colleague, Dr. Lee, I'd like to tell you all a little bit about the manufacturing project that Dr. Lee and I are operating together in Texas. So the presentation will show just a couple of slides. One is the logo, and then another is our portal homepage. The Manufacturing Reshoring Initiative for South Texas was developed by our organization, the United States-Mexico Foundation for Science, the University of Texas, Rio Grande Valley, the Texas Manufacturing Assistance Center, and the McAllen Economic Development Corporation. For the last 18 months, our team has been performing a detailed asset mapping of the South Texas, North Mexico border region with a focus on small and medium-sized manufacturers. Analysis of this data that we're currently collecting via the portal and platform that we developed will provide evidence of gaps and readiness for new opportunities in the region, and will help to indicate the trends and processes needed to help the region become more competitive in the global market. We're currently developing the next phase of the Manufacturing Reshoring Initiative that we plan to launch next year in 2023. So this next phase of the project will take all of our findings over the last 18 months and focus on supplier development, workforce readiness, and company matchmaking in underserved supply chains. We believe that this will lead to investment in the region and help prepare the workforce that will be needed through educational opportunities at the community college and university levels. This is why Dr. Lee and the university in Texas there has been such a great and important partner for this initiative. The proposed Small Manufacturer Initiative along the border is specifically designed to investigate the current challenges and develop a system, tools, and programs to support small manufacturers in the post-COVID era. Now, I would like to introduce my colleague, Dr. Jihanzi James Lee. Dr. Lee holds a President's Endowed Professorship at the University of Texas, Rio Grande Valley, or UTRGV. Professor Lee received his Bachelor of Science degree in Automotive Engineering and Master of Science degree in Manufacturing Engineering from China. He received his PhD in Industrial Engineering from Texas Tech University. Professor Lee has more than 20 years of leadership and research experience in the areas of laser material processing, additive manufacturing, process molding, and optimization, logistics, and sustainable manufacturing. He also has 8 years of industry experience, including business incubation and serving as the Chief Technology Director in IT and logistics fields. Professor Lee is the director of the Center for Advanced Manufacturing, Innovation, and Cyber Systems. He is the founding director of the DoD iDream D4 Consortium, focusing on talent preparation for defense, innovation, leveraging research and education in additive manufacturing and smart manufacturing. He was one of the key members of the management team of the North American Advanced Manufacturing Research and Education Initiative, funded by the Department of Commerce to support rapid response manufacturing at South Texas. Throughout his career, Professor Lee has maintained a distinguished scholarly record and committed to developing new programs that significantly benefit the institution and the manufacturing community. His research and education endeavors are also well sponsored by industry partners and private foundations, including Dell, Honeywell, Caterpillar, GE, Alps Automotive, Boss Foundation, and the United States-Mexico Foundation for Science, among others. So Dr. Lee has had a distinguished career, as you can hear, and I hope you all enjoy his presentation. It's been a pleasure working with you over the years, Dr. Lee, and I will pass it to you.
Thank you, Jessica, for the introduction. And super honored to be here and presenting to a group of friends in the future. You may know me already, but as Jessica mentioned, we've been working together with FUMAC for many years. It's not just me, and my colleagues here at UTRGV has been working with FUMAC since I joined here. So it's been a great experiences collaborating with colleagues from Mexico and colleagues from the FUMAC on the US side. And so today, I don't want to take a long time for the presentation, but I'm a professor. We like to talk more than what the student want. So hopefully, I just want to use this opportunity to spur additional collaboration with our partners and also our collaborators in Mexico. And with that, I want to share with you the PowerPoint, and please let me know if there's a difficulty, see the PowerPoint, hear me. And
Yes, we can see it.
okay, great, thank you. So I'm putting the presentation mode. Jessica mentioned I'm a professor of manufacturing and industrial engineering department at UTRGV. So my topic today is more about, how do we support the democratization of manufacturing in a digitally connected society, especially, based on the reality that UTRGV is located in a U.S.-Mexico border area. So what are the opportunity ahead of us? What are the challenges? And what is our plan, to take advantage on some of the national moments we have, and also the research and workforce development initiative we have in the region. So hopefully we can grow Rio Grande Valley and also our border towns on the other side together, right? So with that, I want to show you a video. I don't know if you you know this guy. So he's talking about how manufacturing is underrated, right? Let me play it. Oh.
Dr. Lee, this is not sound, so you need to share again and share with sound.
Share with sound. Okay. Yeah. Let me
Thank you.
stop sharing. Share again. Share.
There is an option with audio on.
Oh, yeah. Share
Thank you
with
so much.
sound. Okay. Share. Let me share again. Share with sound. Windows.
Like this,
Can
rated
you
and
hear
design
me
is
now?
overrated. So people generally think that this eureka moment of you come up with this idea and that's it. Now it's good. But the design like this, literally 1,000%, maybe 10,000% more work that goes into the production system than the thing itself. So say how much effort have we put into, say, designing Raptor versus designing the manufacturing system? It's 10 to 100 times more effort to design the manufacturing system than the engine.
Even of Raptor?
Oh yeah, absolutely, especially with Raptor. The amount of effort that goes into the design rounds down to zero.
Right.
Relative to the amount of effort that goes into the manufacturing system.
Yeah.
If this
So, really, we cannot, express too much about the importance of manufacturing. And, if you look at the history line, really our history is defined by how do we operate, how do we design the manufacturing tools to make things, to make wealth, to make food. Right now we're talking about, products and for travel, for, communication, for entertainment, everything need to be made. But in US, since the pandemic, we really
This was not true.
get into big challenge of producing things to meet the local demand across the country. So there's some data I want to share with you about the facts about manufacturing. Really, one of the data I think we need to be aware is that every dollar spent in manufacturing would add about $3 to the economy. So it has a high multiplier effects for any economic sector. And 70% of U.S. export come from manufacturing. Now, manufacturing also is the driver for research and innovation. So, according to to the National Association of Manufacturers, 90% of all U.S. patents are coming from manufacturing sectors. It is a higher engine as well. Now, there's a big challenge though. Now the manufacturing industry created more jobs than workers available. So there's a huge need for, workforce development across the country. Now, when people look at workforce development, we look at what? Not only at the young talent we have in the region, but also the skill sets we prepare, our future engineer, the future students about. And the pandemic, is not only a bad thing. It really, forced the manufacturers to consider newer technology, and which going to require new skill sets. For example, we've been talking about digital manufacturing, digital twin, and how do we control a process so that we can manufacture something, maybe 500 miles away, control a manufacturing system, not right away next to you. So you control the production system, which is in a digital world, right? So the manufacturing system could be even on the moon, on the Mars, right? So that we can support some of this, initiative from NASA and from different, ideas we have across the country, including the renewable energy. We have projects regarding how do we fabricate a 100-meter longer wind turbine blade, right? How do you manufacture such a large structure? In the meantime, try to minimize the risk to the workers, right? As you know, fabrication of wind turbine blade is not a good working environment. You have fibers flowing around. So it's one of the area we want to implement automation, autonomy when we manufacture this kind of device. So that's why, in the end, we created so many jobs, but the employers could not find the capable or skilled workers. So based on the National Association of Manufacturers, by 2030, there will be a 2 million gap, right? The cost for this gap is about $1 trillion by, in 2030 alone. There are some other challenges the U.S. manufacturers are facing include, the lead of U.S. manufacturers in terms of technology, advantage has been eroded, compared with the German manufacturers. If you look at the total factor productivity growth, the United States has been in a negative, trend. Only with the machine and equipment and transport equipment, we are in a positive, growth. And also machinery and equipment, mainly because of computer equipment, right? So compared with the US, they have a consistent positive growth from 2004 to 2015. And in the meantime, US is the #1 across the world in the investment to basic science and basic research. So apparently, the investment to science was not translated to, growth in productivity and growth in technology. And so really the government realized, some of the issues we have in the country. So there is a shift of funding priority from the federal agency, including Department of Defense, Department of Energy. And also in US, we have about 99% of US firms are small, medium, enterprises. 2/3 of these SMEs has less than 20 employees. So these are the larger portion of U.S. manufacturing base, and their ability to acquire new technology, to acquire the workforce, to recruit workforce who understand, who can operate high-tech machines is also very limited. So support to this small medium enterprise is very critical for them to be included in the U.S. Manufacturing competitiveness. Now, in the meantime, the manufacturer also consume more than 30% of the energy. So for them to be for the country to be energy efficient, so manufacturing operations has to be reevaluated. The technology need to be reconsidered so that we can accomplish the goal of carbon neutral society by 2050, right? We also have big issues in critical minerals across the supply chain, and the supply chain for literally everything, including healthcare, national defense, and some other areas, been disturbed by the pandemic. And now we also talking about cybersecurity issues, especially involving the supply chain. So focusing on these, issues and across the country and across the agency, there's some new trend, new initiative developed. One of the initiative we call it manufacturing reshoring, and that's one of the reason, we've been working with FUMAC to promote, to create a suitable environment so more manufacturers can move back to U.S. and set up and establish their production facilities here in the valley. So this is not just something happening in the valley. So if you look at Montana, the developing policies to attract more manufacturing operations back to the state. In Arizona, they have the similar initiative across the state. Right. But one of the challenge for every ecosystem is how the big manufacturers or firms to find the local suppliers. So that's why in the reshoring project, we were trying to understand the local suppliers available across the region. If there's some critical suppliers, the sectors which is not in place yet, we hopefully through the reshoring project, we can work with the local cities and work with the EDCs to bring that capability to the region. All right. So across the nation, when you look at the manufacturing reshoring, one of the focus should be how do we develop the ecosystem around 4 critical areas. One is like how do we make sure the ecosystem would be able to connect the firms with customers, right? How do we make sure, the ecosystem would support production of focusing on a certain cluster of products? And how do we develop a talent ecosystem, right? How do we develop a supply chain ecosystem, right? And so all these four ecosystem has to be brought together in order to develop we call it smart manufacturing ecosystem, right? And one thing I think is very important when we do this is how do we incorporate small and medium enterprise in the ecosystem? Because either they're the one who does not have the capability to invest on digital technology. They're the one, who does not have the, ability to handle risks involved in new product and new processes. So they need some help. So one of them at UTRGV at the center we have here, we try to create a pre-competition space for small enterprises, so we can work as a research lab for them. We can provide connection between the small enterprise and the larger firm, and using some of the consortium-based approach and using some of the federal funded project we're running. And also a good example would be for right now, like Joe Biden's administration, they have a newer, initiative called AM Forward. So in this initiative, the government provide fund for small manufacturers so that they can give away 3D printers. And some of the small firms, they can be, considered as a supplier for certain sectors and producing parts using additive manufacturing machines, right? We have additive manufacturing machines for metal, for plastic, which can produce functional parts. So that can actually, fill the gap of suppliers or supply chain if we have some, needs of certain components, and these small firms can produce those parts using the 3D printing technology, available at the university. Now, talking about reshoring, it's not something new. We are working on reshoring before the pandemic. The major reshoring, the source of reshoring are, Singapore, Japan, China, Canada, India, including Mexico. And so after the pandemic, though, the government did a comprehensive study regarding the supply chain issues across the nation. So the reshoring become more comprehensive. We have reshoring, we also have nearshoring. So when we talk about nearshoring, so the government look at developing collaborative relationship with allies, including Mexico, including Canada, so that we can develop more resilient supply chain. Not necessarily everything gonna be made in US, but we try to reduce the risk, reduce the disturbance, the ability to meet, the resilience of a supply chain, the required resilience of any supply chain. Right? For that, the government, the President Biden, Joe Biden signed Executive Order 140710 back in 2021. He demanded Department of Energy, Department of Health, and also Department of Defense, Department of Commerce to evaluate the supply chain for each of these, four departments, so that we can develop a more resilient American supply chain and rebuild the domestic manufacturing capability and rebuild a world-class American manufacturing base and workforce, right? So one of the report I want to share with you a little bit is about the securing the U.S. defense critical supply chain. So the report was released in the beginning of this year, and the DoD identified some high priority area, including kinetic capability, energy storage, battery, casting, forging, microelectronics, and critical minerals. And DoD want to further enhance the supply chain visibility. They have some previous effort to expand supply chain visibility, including using, real-time supply chain management platforms, and also digital supply chain, machine learning, AI, and so on, so that they can make better decision to identify, address trend, vulnerability, and disruption, potential disruptions. So as to the hypersonic industry base, this industry base is identified by DoD as one critical base they want to create, focusing on hypersonic vehicles. And, I've been attending a few workshops organized by the Department of Defense and also National Academy of Engineering. And then one of the key aspects is regarding the workforce development. Now, at the higher institutions, we don't have any education program or training program focused on like a material manufacturing for, material structures required for hypersonic, industry. So that's one of the challenge identified. Even though we've been performing research on new materials, new structure that can sustain high temperature applications, but the workforce, the manufacturing processes is not there yet, right? And then DoD also recognized the needs of energy storage and batteries, which is something every agency is developing program, research, education program, workforce program, so that we can produce more better battery in U.S. So this battery issue is not just for DoD. It's also something for DOE. And back in 2021, the National Blueprint of Lithium Battery was released by DOE, and so they have 5 goals to address the different pillars of battery supply chain, including mining, material processing, cell, pack, production, recycling. So we have some project regarding, material extraction. We are working with Oak Ridge National Lab cell and pack production, and also we are working with another institution at Kentucky, battery and material recycling. So these are the main goals of of the lithium battery. So I sense a huge opportunity here on this new initiative. Now, the other key priority area is casting and forging. So the Department of Defense, realized that the capability of casting and forging has been reduced by 90% in the last 20 years. So now this chart shows the global casting production from 2018 to 2020 by country. The one that dominates the casting production is China, and then India. Then U.S. now only produce close to 10, million metric tons per year. So which is about 90% of our capability, 15 to 20 years ago. 90% of the casting and forging facility were closed. right? So DoD realized, this is a critical area, and they have plans to try to establish new custom forging centers of excellence, and they also try to provide support so that we can develop new custom forging processes or alternative to custom forging, such as new hybrid additive, and subtractive method, and digital production capability as a tool to enhance the traditional casting and forging. Right? So I'm aware there's some custom forging operations around the border, especially at the Maquila, system we have on the Mexico side. But again, I mean, at the UTRGV, we are trying to develop new, we call it America's additive foundry. You got AAF. We try to develop a center of excellence so that we can develop newer technology based on additive manufacturing to replace the custom forging operations. And we did some regional assessments regarding the defense industry ecosystem in the region, and we did a SWOT analysis. And based on that, we also identified some key technology that we're going to develop in the center, including the different additive processes which can be used to to be developed or to be expanded so that we can support the custom forging operations required by the defense. So this is just an example how we leverage on the national level initiatives and opportunities so that we can bring opportunity to the region, to the Rio Grande Valley, and in the meantime, we want to work with the Maquila system on the other side so to become part of the ecosystem we're going to develop in the future. Right. Now, of course, we've been talking about like a digital transformation and material and process innovation. Everything I've been talking so far is you have these three key components: digital transformation, material and process innovation. And especially for digital transformation, so it's the results of smart manufacturing, as everybody is aware. And so really, this going to be the driver of future production, gain, productivity gains. This will be a driver for manufacturing reshoring. So according to survey, most of the company adopted smart manufacturing. They have a gain of, as much as 65% of the budget on smart facility initiative and reported twice the level of labor productivity gains compared with the ones who did not adopt smart manufacturing. However, when we adopt smart manufacturing technology, one of the big questions is about how do we support small manufacturers, right, to adopt smart manufacturing. So that's one of the priority of the manufacturing reshoring project Jessica mentioned earlier. And then right now we at phase one, and at phase two of the project, we will try to recruit small manufacturers and help them to adopt smart manufacturing technologies. Right? And really, this is something critical for our region. And in addition to that, we also support, manufacturing innovation driven by new materials and new manufacturing processes. For example, additive manufacturing. UTRGV has one of the best additive manufacturing research center in the country, in the state of Texas. And so we can, provide technical support. We can allow, any business to consider the UTRGV as a research laboratory for our, manufacturers in the region to support, you guys in development of new materials and new processes, right? And also we also can be can be serving as a bridge so that we can connect the local business and manufacturers to the different Manufacturing USA Institute. So that's another national initiative created by the White House to support manufacturing, U.S. manufacturing. So far in the beginning, the White House created, I think in the beginning, it's 9 institutes. Now we have 16 research institute, right, focusing on a particular advanced manufacturing technology and intended to make early stage scientific research suitable for use in manufacturing production. All right, so this is a summary of the manufacturing institutes we have across the country. So we do have collaboration, for example, with SESME, focusing on smart manufacturing, sustainable manufacturing. And we have collaboration with BioMate, focused on bio manufacturing, recycling, and sustainable manufacturing, sensors, and so on. And the other one would be American Mix, which is American Mix, focused on lightweight materials, new materials, material processing, and additive manufacturing and 3D printing. And then we also have collaboration with the other ones like, ARM. This is the summary of the Manufacturing USA Institute and what they support in terms of early stage scientific research for manufacturing operations. So you can see here one of the focus is about lightweight material, lightweight metals, right? So that's the focus of UTRGV, Center for Manufacturing Innovation. And there's another one called additive manufacturing, right? That's another focus we have. And hybrid electronics, advanced composites, wide gap, semiconductors, pharmaceuticals, digital manufacturing, advanced fabrics, clean energy, and so on, and photonics. So if you are looking for some help that, to connect to this institute, we can be considered as a bridge to connect you with this institute and get some support, not only in research, but also in workforce development. Now, there's another trend right now in the country is about convergent manufacturing. That is, how do we combine multiple materials, multiple processes in one process so that everybody can produce a part out of multiple materials. So this is a super good idea for smaller business, for some smaller manufacturers. It's like in your kitchen. Back then, we don't have those kind of facilities we have in the modern kitchens, right? So really, when you can combine different things in one system, then you can bring the factory back to your home, right? So that's why in the beginning I said we want to bring the democracy for U.S. manufacturing. Really, that means what? Every person can have access to a factory, to a machine, and make things and providing contribution to the manufacturing base in U.S. I skipped this part, also this part. So one of the things I want to talk a little bit is about iDream4D, which is the consortium we created and UTRGV is leading and founded by Department of Defense. The focus of this consortium is to provide provide the talent needed for the Department of Defense, for the defense, defense contractors across the country. So we have both institutional members defense laboratory members, and also defense contractor as members, right? So across the country. And the focus is on, from the research perspective, we focus on additive manufacturing and smart manufacturing. And the UTRGV is the lead. We also have UT Austin, UT San Antonio, Virginia Tech, and Virginia State University as the participating institutional members. We are recruiting additional members, to join the consortium. So, really, we hope through the iDream 4D consortium, we can provide the connection between the small manufacturer to the large firms, and also to the defense, link the small firm to the defense manufacturing ecosystem. Now we do a bunch of research. I want to skip this one, but as I said, we're performing research on convergent manufacturing with a goal to be able to process multiple materials. We want to further increase the deposition rate of additive manufacturing. So hopefully in the end, additive manufacturing can be used as alternative process, to replace the casting process. We also have additional, research on, for example, in situ alloying, and additive manufacturing for extreme conditions supporting the high temperature corrosion load environment. We have project on in situ monitoring and using machine learning and AI for rapid qualification. We do have some other project for regenerative medicine and printed circuits, printed and embedded electronics and sensors. So recently, we received another large funding from DOE. It's about $4 million funding. Also leverage on the advanced additive manufacturing research and education, but this one focused on renewable energy devices and energy systems, including battery, including solar fuel cells, energy efficiency, tooling, automation, and recycling, and smart energy. So this one we have 2 national labs, including Oak Ridge National Lab, Los Alamos National Lab, and 3 institutions. UTRGV is the lead. So this time we also have University of Arizona, participating in the consortium. Now this is an example of some of the project we are working on. This is called concentrated solar power. So in this one, we are using additive manufacturing to produce parts, produce the tubes with internal fan structure. This fan structure can enhance the heat transfer efficiency or coefficiency, and which is critical because this tube's going to be put on at the top of the tower here, and inside the tube we have molten salt. So the tube gonna collect the solar energy and then transfer to the molten salt, and the molten salt gonna power the heat exchanger, which produce high power steam, which power the steam turbine and produce electricity. So the concept is very similar to the coal-based power plant. But instead of burning the coal, you use solar energy. And the solar energy is very simple. These are the mirrors. Thousands of mirrors reflect the sunlight to the top, which power the turbine. So think about it. In Texas, we have no solar energy, concentrated solar energy available in the state of Texas, but we have lots of sunlight. So that's one of the projects we try to work on, and hopefully we can contribute to the renewable energy production in the state of Texas. And the Department of Energy, they have 3 demonstration sites. There are 2 in California, 1 in Nevada, but there's none in Texas. The other one is Arizona. So through this project, we hope we can bring some renewable energy opportunity, our project to the state of Texas. Now, very quickly, I think I want to give 2 minutes talking about the Center for Advanced Manufacturing Innovation Cyber System available at the at the UTRGV. So as I said, we focus on 3 main areas: material structure and product innovation. The second area is about advanced manufacturing processes. The third area is about cyber systems. So if you have any needs in these 3 areas, we welcome collaboration. We would love to work with our Mexico counterpart and working on this research, education, development project. If you have any difficulty, if you have any ideas, reach out to us. So in the end, we try to make UTRGV as the powerhouse for binational manufacturing, education, research, and innovation, leveraging our connection with larger manufacturing firms, our collaboration with federal agency, including DoD STEM, Society of Manufacturing Engineers, Manufacturing USA Institutes, and additional stakeholders. And from education perspective, we are developing not only the bachelor program, Bachelor of Science program, Master of Science program, PhD program. We also have certificate program. We can design the program based on the industry needs and based on the modules we have, the module you would need us to develop and provide tailored education opportunity for our industry partners. And again, I mean, we try to be focusing on the latest technology. We try to grow, consider the population, the communities around the border to be our targeted, audience. It really is about binational, and UTRGV has a strong plan to support the binational communities. We have, for example, I cannot speak Hispanic, but we do have faculty members who are bilingual, who can talk in both English and Hispanic. So we try to reach out, we try to deeply engage in our community. And UTRGV College of Engineering has been very successful in external funding and also enrollment. This is the enrollment data we have. So this year alone, in fall 2022, we have 1,000 new students, enroll into the college. So we want to have more students from Mexico side. We have special tuition waivers for Mexican students, right? And we can also serve as a research and innovation firm, and a facility for all small, medium enterprises. We can help to provide global market for the Rio Grande Valley small, medium enterprise through our national networks and the global presence of UTRGV and FUMEC. We want to serve as a bridge that link large firm with the smaller firm, promoting manufacturing reshoring. We will acquire necessary physical and digital infrastructure to support research, economic development, education tailored to your needs, right? We have, program, we have federal funding to acquire additional manufacturing equipment, such as new additive manufacturing processes, instruments, and other convergent processes and tools that will support the needs of our local manufacturers along both sides of the border. So again, the picture here is one of the lab we have, and this is the EOS machine, metal additive machine we have, and we have lots of activities, you know, involving hundreds of students working on both on research and projects from industry or funded by the agency. We also have internship programs that are going to send students over to our industry, you know, partners. Again, I don't want to, you know, spend too much time. I think I have 45 minutes. I hope that's something, you know, but before I finish here, I also want to recognize Mr. Keith Patridge, you know, and he's been a key team member and partner for the College of Engineering and Computer Science, you know, since I think back then in 1980s, 90s, he started the manufacturing, not the manufacturing, the engineering, the College of Engineering at UTRGV, and he's been supporting not only the college but also the team we have here, and especially with FUMEC, you know, on different projects. So he received major recognition this summer. So for us, community partners are very important. We want to make sure our research education directly support our local community. So our success will be, you know, your success. Your success means that we are successful. So with that, I want to, you know, stop. And I don't know the next step. Do we have any question answers? But
Sure. Thank you so much, Dr. Lee. Thank you for your presentation. Dr. Lee shared with us kind of a great overview of kind of what their university offers in terms of binational focused education, research, and innovation for manufacturing. UTRGV is actually poised to be the second largest Hispanic serving institution in the United States, which is really significant. And our board chair, Keith Patridge, made the introduction to FUMEC and the UTRGV region there. And I think what's made our project successful and what's really made the university so successful is that they take into account the binational, bicultural, bilingual community that they serve that really is very unique to other places in the country. So again, it's been a pleasure to work with Dr. Lee. We have a lot of new exciting projects coming up, but I know we have 5 minutes. So we did want to open it up to any questions. So if anyone has a question, you can type it in the chat. And Marcella and I can field them to Dr. Lee.
Thank you, Jessica. Thank you, Dr. Lee. Muchas gracias a todos. Así los invitamos, así tienen algún comentario o alguna pregunta, lo pueden escribir en el chat. Asimismo, si gustan continuar esta conversación offline, pueden compartirnos su correo electrónico o podríamos también les vamos a escribir en el chat el correo electrónico del evento en donde podremos dar seguimiento a sus peticiones, comentarios, dudas, sugerencias. Parece que hay una pregunta.
Not a question, but a comment from Eduardo Solis, stating that the manufacturing operations in Mexico support all different initiatives. Defense manufacturing in Mexico is present widely in the aerospace industry. Let's capitalize on this. Glad to further discuss. So Eduardo, we can follow up with you and connect you with Dr. Lee offline, and we'd be happy to set up a meeting to continue that conversation. Dr. Lee is very well embedded with the Department of Defense, anticipating the future workforce needs, and increasingly important in the United States as, now we have national security reasons to bring a lot of defense manufacturing back to the United States, back to North America specifically. So this is something that I think Dr. Lee and his research and his work has been really forward thinking about. So we'll be happy to connect offline to talk about this more. Are there any other questions?
It seems not at this moment.
Okay.
So, a todos les agradecemos mucho su participación en esta ponencia y los invitamos a que en 2 minutos nos reconectemos continuemos en esta sesión, y continuemos con la ponencia electrónica avanzada y semiconductores, oportunidades de formación de capacidades para la región de Norteamérica, en donde Mariano Contreras y Carlos Meneses del equipo de FUMEC nos presentarán este interesante tema. Muchas gracias a todos. Thank you so much, Dr. Lee. Thank you so much, Jessica. See you soon.
Great.
Thank you.